Welcome to Metrology lecture series. In the present video, we will discuss the measurement of internal taper of blind hole and the taper ring by using the precision balls and the rollers. Balls and rollers are used to find the taper angle when the ends of a conical hole or shaft are not directly measured by instruments like a protractor. These balls and rollers are special measuring tools used along with the gauge blocks to check the linear dimensions and the angles in mechanical parts. Balls and rollers are made from high quality hardened steel, so they do not wear out easily. And moreover, for the rollers, the length is the same as their diameter so that the shape is accurate. In general, availability in the many small sizes, that is from 1 mm to 25 mm in diameter, by placing them in gaps or tapered parts and measuring over them, we can accurately find the size, gap or taper angle of a component. First we will discuss the how to measure the angle of the right tapered workpiece. This is the right tapered workpiece and consider angle is the theta. So let's consider this angle is the theta. Angle of the right tapered workpiece is measured by using the two rollers of different sizes, slip gauges and a dial indicator. Two rollers whose diameter are known and slip gauges are placed on a surface plate as shown in the figure. Let's observe the figure. Here two rollers which having the different in diameters are placed on the surface plate and the distance between these two rollers are measured by slip gauges which is placed in between the rollers. The rollers may be clamped in position against an angle plate by the C-clamps. Similarly, workpiece also clamped by the using the C-clamps. If the taper angle of the workpiece is correct, the top surface will be parallel to the surface plate. Then, when the dial indicator moves along the top surface, it will show no change in the reading. So, we have to adjust the roller's distance up to the workpiece top surface is parallel to the surface plate. This parallel to surface plate is checked by the dial indicator. If the dial indicator reading is no change, then top surface of the workpiece is parallel to the surface plate. Let's start the derivation to determine the angle of the right tapered workpiece. Let's consider D1 equal to diameter of small roller, D2 equal to the diameter of big roller, and L equal to the length of the slip gauges or distance between the two rollers. Let's consider O1 is the center of the small roller and O2 is the center of the big roller. So first we have to draw a straight line, that is the O1A, which is parallel to the surface plate. Next we have to join the two centers of the rollers, that is the O1 and O2. So draw a line O1, O2. Next we have to draw a line O2A. So here observe the right angle triangle, that is O1, A, O2, with the angle of the theta by 2 is forming. So here observe the right angle triangle O1, A, O2 with the angle of the theta by 2. So next we have to write down the based on the right angle triangle. So tan theta by 2 equal to the O2A divided by AO1. So next we have to calculate the O2A and the AO1. So from the figure we have to observe the, so this is the O2A. So we have to determine this value. So we know that one, this is the D2 by 2 and this is the D1 by 2. So here observe the here. So this is the D2 by 2 and this is the D1 by 2. So then O2A will become the D2 by 2 minus D1 by 2. And similarly we have to observe from the figure AO1 equal to the D1 by 2 plus L plus D1 by 2. Then tan theta by 2 equal to the D2 by 2 minus D1 by 2 divided by D2 by 2 plus L plus D1 by 2. So remember this equation. So this is the for the determination of angle of the right tapered workpiece. Next we will discuss the external taper measurement or determine the angle of taper plug gauge. So this is the taper plug gauge and this is the schematic representation of the procedure to determine the angle of taper plug gauge. Let's see the procedure to check the external taper angle using rollers. So first we have to place the smaller end of the taper plug gauge on the surface plate. So in the schematic we have to observe. First we have to place the smaller end of the taper plug gauge on the surface plate. So then first two rollers of equal diameter are placed touching on the opposite sides of the lower surface of the plug on equal height of the slip gauge combinations on either side of the gauge and measure M1 using a micrometer. So next we have to place the two rollers of equal diameters which is touch the gauge at the opposite sides. So I have to observe here. So this is the two rollers. So which is having the same diameter. So this is have to place at the lower end of the gauge and moreover it should be touch the surface of the plug gauge. After that one we have to keep these rollers with the combination of the slip gauges at the equal height at the both of the side. Let's consider this height is the H1 at the both of the side. After that we have to measure the M1. So this is the M1. So the distance between the rollers. So with the help of the micrometer. Then the rollers are placed on increased height of slip gauge combinations on either side of the gauge and measure M2 using the micrometer. So after measuring the M1 value, next once again I have to place these two rollers another location by increasing the height of these slip gauges. Let's consider the H2 and both of the side let's consider the height is the H2 and it should be touch the another position of the plug gauge surface. Let's consider this is the height is the H2. Once again I have to measure the distance between the rollers M2 with the help of the micrometer. Let's start the derivation to determine the angle of taper plug gauge. So this is the M1. So distance between the rollers at lower position, and this is the M2, distance between the rollers at the upper position, and this is will become the M2 minus M1 divided by 2. So it is this value will become the m2 minus m1 divided by 2. So next we have to join the centers of the rollers at the lower position as well as the upper position. Let's consider O1 is the center of the roller at the lower position, and let's consider O2 is the center of the roller at the upper position. So first we have to join these two centers. So next we have to draw a horizontal line from the O1, and similarly have to draw a vertical line from the O2. So now have to, these two are the intersect. Let's consider at the point is the O. So now have to observe. So right angle triangle is forming with the angle of alpha. So this is the alpha because here. So this is the vertical line to surface of the plug gauge. It is the angle alpha. Similarly here also it is the vertical line, and it is the parallel line for the surface of the gauge. So it will become the alpha. So here one right angle triangle. So O, O2 and O1 with the angle of the alpha it is the forming. So from this right angle triangle, so we can be determine the angle alpha, and this value will become the H2 minus H1. So because up to here H1 and up to here it is the H2. So it is the plus diameter D and this is the plus diameter D. So this distance will become the DD will get cancelled. So this distance will become the H2 minus H1. And similarly this distance will become the M2 minus M1 divided by 2. So we know the alpha and we know the H2 minus H1. This height also we know and this length also we know. So that is the M2 minus M1 divided by 2. So from this right angle triangle we can be written as tan alpha equal to M2 minus M1 divided by 2 divided by H2 minus H1. Then tan alpha equal to the M2 minus M1 divided by 2 into H2 minus H1. Next we will discuss the measurement of internal taper of blind hole or measurement of the angle of taper ring gauge. So figure shows the arrangement for checking the internal taper of a taper ring gauge by using of two precision balls of the different sizes. The ring gauge is placed on a surface plate and a small ball of radius R1 is inserted in the hole which is close to the small end of the taper. So first I have to place the ring gauge on the surface plate and insert the small radius. Let's consider R1. So small radius ball is inserted which will be reached close to the smaller end of the taper. Next two piles of slip gauges of equal heights are then placed on the surface plate on either sides of tapered ring gauge. So next we have to place the equal height of the slip gauges on the surface plate at the both sides of the tapered ring gauge. Next a depth micrometer is used to determine the distance from the face of the gauge block to surface of the precision ball. So next we have to use the depth micrometer. So with the help of the depth micrometer, so have to measure this distance. That is the distance from the gauge block to distance for the surface of the smaller roller. So this is we have to measure. So if you measure this one, So we will get the H1 value also. H1 is the height of the top surface of the smaller roller to the surface plate. So after determination of the H1, so next once again we have to insert the bigger roller. Then bigger roller of radius R2 is placed in the hole near the big end of the taper, and the distance from the top face of the gauge block to surface of the bigger roller is determined with the help of the depth micrometer. So after determination of H1, next once again we have to insert the bigger roller. Let's consider radius is the R2, which has to be settled at the near the big end of the taper. Then once again I have to measure the distance between this bigger roller surface to this gauge block surface with the help of this depth micrometer. So if you know this value, we will get the H1 also. Let's consider H1 is the distance between the top surface of the bigger roller to surface plate. So if you know the H1 value, let's consider H2. So H2, and this is the H1, and this is the R1, and this is the R2. And let's consider O1 is the center of the smaller roller and O2 is the center of the bigger roller. Let's see the derivation to determine the angle of the taper ring gauge. First we have to draw a line O2C, which is the perpendicular to the workpiece surface. So next we have to join the centers of the two rollers, that is the draw a line O1 to O2. Then we have to draw a line from the O1 which is parallel to the workpiece surface. It has to be intersect the O2C line at point S. So now here you have to observe one right angle triangle is forming, that is the triangle O2 O1S with the angle of the theta by 2. So from this triangle we can be say that one the sin theta by 2 equal to the O2S divided by O1 O2. So now I have to determine the O2S and the O1 O2. So here O2S will become the O2C minus CS. So here O2C, which is equal to the radius of the bigger roller, that is the R2, CS, which is equal to the radius of the smaller roller, that is the R1. Then O2S equal to the R2 minus R1. So we can be written that O2S equal to the R2 minus R1. Next we have to calculate the O1 O2. So this distance we have to calculate. So here to, up to here, so this is the H2 and this is the H1. So this is the H1. So this distance is the H2 minus H1. So this distance is the H2 minus H1. But we need the from here. So then we have to subtract the R2. And also we need the up to here. Then we have to write down the plus R1. So this is we can be written as H2 minus R2 minus of H1 minus R1. So that is the O1 O2, which is equal to the H1 R2 minus of H1 minus R1. Then sin theta by 2 equal to the R2 minus R1 divided by H2 minus R2 minus of H1 minus R1. Next we will discuss the measurement of tapered ring gauge angle. So first I have to place the one end of the tapered ring gauge on the surface plate. Then place suitable slip gauge combinations, that is the M1, in between the two rolls such that both balls arc in contact with the internal side of the ring gauge. Next, to place the reverse end of the tapered ring gauge on the surface plate and repeat the above procedure for the reading M2. So next we have to measure the height h of the ring gauge with the vernier height gauge. Similarly, we have to measure the diameter of the balls with a micrometer. So next, let's see. Next we will discuss the derivation of the taper angle alpha. So here capital H is the height of the tapered part and small d is the diameter of the ball, and M1 and M2 is the distance between the two rolls at the upper position and the upside down position. So here observe that one right angle triangle is forming with the angle of the alpha. So from this one we can be written as the tan alpha equal to M2 minus M1 divided by 2 divided by H minus D. Then tan alpha equal to M2 minus M1 divided by 2 into H minus D. So this is the measurement of the taper angle with the help of the balls and the rollers. Thank you.